Okay, so let's get more familiar with the periodic table. For these discussions, please make sure you have a periodic table in front of you to refer to whenever it calls for. We'll talk about the periodic table, the basis of the periodic table. We'll talk about the different terminologies that go with the periodic table, and we'll also very briefly touch upon something called chemical periodicity. You're not expected to know more than that. We are not going into the details of any of this. The periodic table is based upon something called the periodic law, which says that if elements are listed in increasing order of atomic numbers, elements with similar chemical properties reoccur at regular intervals. So it becomes more predictable. And the periodic table, basically, if you notice and peruse through it, is exactly that. It's a list of elements in increasing order of atomic number, Z values. And when that happens, elements in the same groups, in the same vertical columns, end up with similar properties. It is very useful because that allows us to make general predictions about properties, general predictions about what elements would do or behave as under different situations. A periodic table, as we said, is basically a combination of rows and columns in which elements are listed in there based upon their atomic number, the Z value, which also equals to the number of protons in the nuclei of each atom. And for an atom, please remember, number of protons equals number of electrons. The each cell in the periodic table is houses one element, and that is represented using its one or two letter symbol. Above that symbol is an integer value, that's the Z value, and below that symbol is the average atomic mass of the element in units of AMU. The vertical columns are called groups, and these are sometimes also referred to as families. It's the elements in these vertical columns that have very similar properties, that behave very similar to each other. There are two kinds of groups that we will discuss and go over and familiarize ourselves with, and those are groups that fall under either have a letter uppercase A associated with them or uppercase B. Now look at the periodic table and look on top of each column. On top of each columns, now depending on the periodic table you are looking at, may have an Arabic number or a Roman number. We, for the purpose of this class and other chemistry classes, we will only use the Roman number. That's the only one we use. And this Roman number, if you look very closely on top of each group, each column, has a letter either A or B associated with it. So please take a highlighter or a colored pen and highlight the Roman number with the letters A or B associated with them. Those are the ones we will use for our discussions. The horizontal rows in the periodic table are called periods. These are, so basically the periodic table is a combination of groups, vertical columns, or periods that are horizontal rows. Now, depending on the periodic table you're using, it may or may not have a number listed on the left hand side of each row. So basically you can go ahead and do it if your periodic table doesn't have it. Row number 1, period number 1, is the one that has hydrogen and helium in it. Row number 2 or period number 2 has lithium, beryllium, and then skips over to boron, carbon, nitrogen, oxygen, fluorine, neon, so on and so forth. Row number 3 or period number 3 starts with sodium. Period 4 starts with potassium. Period 5 starts with rubidium. Period 6 starts with cesium. And period 7 starts with francium. So if your periodic table doesn't have the row numbers or the period numbers listed, you can do that yourself. If you notice very carefully in the periodic table that you are looking at, there is a skip in the Z value in period 6 between Z 57 and 72. And then right below that, there's another skip in the z-value between 89 and 104. And if you notice at the bottom, there are two rows that are separate from the main body of the periodic table, which actually, if you focus on the z-value, fit in those two missing spots. So if you were to actually arrange all the elements completely in the order of their z-values, the actual shape of the periodic table would be as shown. However, for convenience purposes, these elements right here are pulled out of the main body of the periodic table and are arranged at the bottom of the periodic table. So the modern day form of the periodic table is one that has the main body, and then below that are two layers of elements that would have ordinarily fit right there.